Okay, so I'm so happy to present Giuseppe Paolo, the very first guest of this podcast that I'm doing called I Scientist. I'm really nervous. Are you nervous?
Yeah, I'm quite nervous. It's one of the first time I do this.
Yeah, for me the same. The first time I'm hosting a podcast. I'm also very excited. There are a lot of subjects I want to treat with Giuseppe. So Giuseppe is a young scientist who did his PhD in Sorbonne in 2021 in reinforcement learning, which is one of the exciting subdomains of AI, and we will talk about this. And he joined my team in Huawei Research France in the same year, where we are actually both of us are working on reinforcement learning. So this is going to be let's say, the technical subject of this podcast. We will try to bring it closer to the audience. But I also want to bring Giuseppe close to the audience, the person behind the AI, right? So my first questions will be about, how did you end up becoming a scientist? When did it ever first occur to you to do this?
Okay, well, first, thanks for having me. I'm super happy to be here, a bit nervous, but very excited. So to answer your question, I think it was a bit when I was a kid. When I was a kid, I was very curious about stuff. My mother used to call me screwdriver's hands because I will always tear apart stuff to figure out how it works.
That's so very familiar, yes.
Yeah. And so since then, I was very curious about how things worked, how the world works, how to understand things. And I think it's there in little by little. Then I figured out I wanted to be an engineer when I went to university. And then there is one book that really moved me towards AI in general and artificial intelligence. That was Thinking Vehicles from Breitenberg. It's a very small book that starts without thought experiments, building small robots. Then little by little you add parts and become more intelligent. So that also pushed me from the engineering side to the science side, pushed me to do robotics, then AI, because I wanted to make stuff like that, stuff that can act in the world, understand how it works, figure it out by itself. I also understand how human thinks as well.
So that was also your motivation.
Yeah. So I have a friend that actually is doing a PhD in neuroscience and trying to understand how humans work from the point of view of humans, studying intelligence. For me, from my point of view, I'm doing the exact same thing, more or less, but moving from the other end of the spectrum. So studying humans by building it up from scratch.
Otherwise, you could have been a mechanical engineer or somebody who does the engineering part of the robots, right? But you were somehow interested in the algorithm part. What's happening in the brain, right?
Yeah, exactly. It's what I find most fascinating because it really helps to understand the world. I mean, you can have a super complex mechanism, but if it has no intelligence about what it's doing and how the stuff around itself work, it's boring from my point of view.
So how did your family react?
So when I went in the engineering part, they were happy. They were like, "Oh yeah, he's gonna easily find a job. He's gonna study." So that's positive. When I told them I wanted to do a PhD, they were like, "Yeah, okay, that might be interesting. So he can become a professor." But during my PhD, my parents and my will always joke that I was not really working. I was just spending my time playing and studying.
Sometimes I feel this about my work because it's so much funny.
Yeah, exactly. I mean, when I work, I feel like a bit I'm playing because I play with ideas in my head, with other people's ideas. That is super interesting. But there is this joke that always makes me laugh from my grandfather when he told me when he asked me what I was doing. I told him I'm a researcher. I research stuff. So he asked me, at the end of my PhD, you've been always searching, but have you ever found anything?
That's funny. Actually, I have a question on this. Like, because I remember very vividly the first time I sort of discovered something. At least I thought I discovered it, then I found it in an old paper. But it doesn't change the feeling of doing something that you think has never been done. Have you ever a memory of such a discovery? Of the first thing?
So I don't really have a specific memory, but I know the feeling. So sometimes even in my research, when I implement a small thing, I say, yes, that works. I'm so happy. I was not expecting that. Then yeah, it happens very often that you find someone else that did it, but that doesn't remove the excitement from it.
Yes. Yeah. So maybe let's delve into the technical part. I want to make every episode about one of the domains of AI, which is very technical. I'd like to bring it closer to people, and the topic reinforcement learning that you work in it's for me it's very interesting. If you know GPT, reinforcement learning appears there in an acronym. RLHF, which means reinforcement learning with human feedback, that they used on GPT-3 to rein it in, to make it less offensive. So reinforcement learning starts to be known in the general public. It was also when AlphaGo beat Lee Sedol. That algorithm was also a reinforcement learning algorithm, but it may be less well known, let's say, image classification or language generation. So I'm interested in your sort of explanation of reinforcement learning to an 8-year-old. And then also why you chose reinforcement learning as your research topic.
Okay. Well, so this is the way I will explain it to a kid, and or I explain it to my grandparents actually.
That's actually.
So it's like when you're trying to teach a dog to do something, what you do is that you give it little threats. So if it does what you want it to do, if you tell him to sit and the dog sits, you give him a threat. If you tell him to tell it to sit and the dog starts to run, you scream at it or you try to rein him in. And this is a bit the concept around which reinforcement learning is built. Is the concept of reinforcing. So if you build an agent and you want it to do a task, that doesn't matter which kind of task, if the agent, and you let it kind of play, so you let it try different things, if the agent starts to get closer to the task you want it to accomplish, you give him a positive reward, so you reinforce that behavior. If it does anything else, you give it a negative reward, a punishment to give it a negative reinforcement for that behavior. So little by little, by reiterating through a process of trial and error, the agent will hopefully, because it's not always given, reach the point when it can learn the task. And to talk more about the branch of reinforcement learning I work on, I work on model-based reinforcement learning, which is a sub module of reinforcement learning, you can say, in which you still have this concept of having to learn a task through trial and error, but this is accompanied by the fact that you want to learn a model of the world. For example, if you're trying to learn how to cook, in your head, you have a model of how the kitchen works. If you light up the flame, light up the flame of the stove, the pan starts to warm up, so you can put the oil that little later it will start to fry. So what we're trying to do is to have an artificial intelligence that can learn a model of the world like this. So by trial and error, it understands that for each action, something happens. And this way it can plan. So it's like it can act like we do in our imagination. going back again to the cooking thing, you know in your head the steps to follow, so you have a plan on what you have to do to fry an egg, so you follow that because you know how the kitchen works. If you've never seen a kitchen, you will never be able to do that. So if we can have an artificial intelligence that has a model of the world around it, then it can do different things. So that's the hope, or where we're trying to get.
Yeah, so we'll get there. I still want to dig in a little bit on the different components of such a system. If we look at what we call model-free reinforcement learning, all we do is the feedback that we give to the dog, and the dog has a way to absorb that feedback and learn what we call an agent. And it's an interesting concept, the agent, because what we really learn in reinforcement learning is how to act, right?
Yeah.
It's opposed to other algorithms in AI, which learn, for example, how to classify an image. It's sort of like a passive output of an algorithm. Or even in GPT-3, the original model, I just learned the statistics of words using most of the written language that we ever done to predict what comes as a next word in a sentence. But there was not much agency there, even though like putting there out the next word could be considered as an agent, right? So it turns out that sort of approach to reinforcement learning is very hard, right?
Yeah.
You need a lot of samples, and this is why most of the time it's only used in games like AlphaGo, because games can be simulated. You can have as much experience as you want by simulating it on a computer. And so we both in love with model-based reinforcement learning because it seems to need much less examples to learn, and it's much closer to what we do. So the components, so tell me a little bit about the three components, what we call the actor, like an agent behind the acting, the model, and the planning. So three components that actually map to what we do.
So we have these three components because so the acting is actually the policy we want to follow, like that it learns what to do at every different state. So what the state, going back to the dog, we want it to learn to sit. It knows that if it's standing, the next thing to do is to lower his rear legs. So that actually follows a policy, and is the actor is what actually makes the agent do things. So that is one of the most important part in reinforcement learning, because it's actually both in model-free and model-based reinforcement learning what we want to learn. In model free is a bit more explicit because we're actually aiming. This is what we directly learn most of the time. Instead, when we learn a model, that then this model, this imagination of the world, we can use it a bit like even for other things, because the thing is, if we learn an actor, that actor will mainly only be able to do the thing that he learned. Instead, if we learn a model, we can use this model to do other things. I mean, if you're going back to the example of cooking, you know how the stove warms up the pan, but so you can use it to cook pasta, to cook an egg, to cook meat, and you can do multiple things. Instead, if you just learn the actor, it will only learn to cook, to use the pan to cook an egg. So if it needs to learn how to cook pasta, it will probably have to learn from scratch how to heat up the pan and everything. So this is one of the reasons I prefer a model-based, because it lets you build this model that then you can reuse whatever you want. So at that point, rather than having to relearn the actor, which, as you were saying, is kind of expensive because it also needs a lot of samples. Once you have the model, you just need a different planner. That's the other component, in which is much less expensive to have, because you can also have a super simple thing in which you simulate different things in the model, and this and then you choose the one that actually is more aligned with your task, with what you actually want to do.
Yeah, actually, I like to compare planning to actually thinking.
Yeah. Mm-hmm.
So basically, we know from cognitive science that we have a model of the world.
Mm-hmm.
That model of the world is there to predict what's going to happen if I do this, if I do that, or if I don't do anything, I just look at the world and predict where it goes.
Yeah.
There's a lot of learning of this type of knowledge.
Mm-hmm.
And that's the nice thing about the model. Another nice thing, you can reuse it for different tasks, but it's also doesn't change.
Yeah.
Right? You can change the way you act, these things you do in the world, but if you do something in different ways, like push the glass on the floor, it will break, and that part of the world is sort of what we call objective. So that's something that's easier to learn than how to act, because how to act, it can also depend on your own policy, right?
Yeah.
So that's why reinforcement learning is so hard, and so much harder than what we call supervised learning behind ChatGPT or the image classification model. So one example I thought when you were talking about cooking with planning is that, let's say you decide to cook an egg, and you plan in your head, you put the oil, and then you break the egg, you turn on the gas, and you put it in, and you wait 10 minutes. And so the first thing you do of this, so you plan the sequence of actions, right?
Yeah.
First thing to do is to take the oil.
Yeah.
And then you realize that you don't have oil at home.
Yeah.
So then you replan. It's also, if you think about like Google Maps, when there's an accident that it was not predicted by Google, and you arrive there, it has to replan. So that module in the mind of the reinforcement learning agent of this whole thing is important. And the reason why it's important, because we can plan as long as we want. This is almost like we confabulate the future. We try to predict it, but there are a lot of different paths and a lot of different uncertain things that can happen in the world on that path. So it's better just to you plan it, you think you'll arrive there, you just execute the first step of that plan, and then you see what happens. So it's much more natural than doing reinforcement learning without planning, where you have just an agent and it goes ahead whatever happens. So it seems like planning can correct its errors, right?
Going back, thinking about the Google Maps example you gave, is like if you don't have a planner, it's like you reach the place where the road is closed, and then I have to relearn how to drive to reach the new to do the new path and go where I want to go. And instead, if you just have a model, you can, as you were saying, plan in it, imagine different things you can do, and maybe, I don't know, park your car, take a bus. So you don't really have to relearn from scratch. From my point of view, it's much more flexible. And I like your analogy of thinking, or like where planning is like thinking, because it's actually very close to what we do.
Yes. The other thing I like about reinforcement learning is that the algorithm is responsible for collecting its own data. Right? Whereas like GPT-3 was trained on an immense data set that was collected by the researchers at OpenAI and others. Okay, so it was some open databases and some other curated text. And that is somehow unnatural to me, to claim that something is intelligent that was just fed data and passively does something, as opposed to somebody who actually has a goal and collects the data it needs to learn the world to achieve that goal. See this?
Yeah, I see what you mean. Yes, I agree. But it also depends on the definition of intelligence you have, because you can imagine the way ChatGPT has been trained in a supervised way as a way to build a model of the human global consciousness. So once you have that model, then you can, I wouldn't say plan, because that's not the exact analogy, but you can use it for different things. So yeah, it's not straight up full intelligence. Also because I think to have intelligence, you need to have some kind of agency. So like being able to decide what you want to do in a way, not only to solve a task that is given, but even give yourself a task. That
Exactly. Yes. And even further, maybe to be able to create your own value that you want to optimize, you want to get after.
Yeah, exactly. That goes much closer to what human-like intelligence is.
Exactly. So yes. Go ahead.
I mean, it's not given that what we can call human-like intelligence is the only kind of intelligence that exists, but is at least the one that we're more familiar with, and we can see a bit of it also in other animals. So at least on Earth is the most realistic one we have. Then we can imagine other kind of intelligence, but we don't know what that will mean, and even if it can be useful somehow. I mean, ChatGPT is useful for some things, but
so I'm a very left hemisphere thinker. I matured into somebody who can also use the right one, but left hemisphere is known about making systems, putting order in chaos. And so one of the frameworks I like very much that actually relates to this concept of learning an agent is John Vervaake's 4P. And I won't talk about it because it's a complicated subject, but the first 2P he calls propositional and procedural. Propositional knowledge is basically what can be put into the proposition that you write down, like a statement that can be either true or false. Everything that's written, all the knowledge that is written, is propositional knowledge. Whereas he calls procedural the knowledge to know how to do. Like propositional is what is true, and procedural is how to do to achieve something.
yeah.
And I see very much reinforcement learning as instantiating that second level of knowledge, where we learn how to do to achieve a goal, to achieve something which has value for the agent who learned. Now, the interesting thing for me that value is still coming from outside. Like in most of the algorithms, we define the value, or it's a game where the value is winning the game. For the dog, the value is the cookie gets or the stroking. And we as humans have also the capacity to decide what's valuable. And those come from higher level P's that I will not talk about. But we are very far from that. So even the agents that act in the world don't have that that capacity of automatically deciding what is valuable. I'm talking about this because the next subject I want to talk about is there's a lot of fear from AI today. And I think one of the fears is that if we give agency to these very powerful algorithms that seem to be smarter than anybody else in the world, like GPT, but we don't give them the ability to be in the world, then if we give a task to this agent, like the typical example is to make paper clips, then on the way to make those paper clips, it will destroy the world because its only goal is to make paper clips, and it's very smart to decide how to make paperclip. So what do you think about this scenario? Because this is one of the basic scenarios that is going around now in the public.
Yeah, so I have a bit of a mixed feeling about this thing, because from one part, I think is the most likely among the AI Armageddon, all Armageddon scenarios. I cannot imagine an AI becoming evil just for the sake of it. Like it will more likely that it will be more likely that something a bit less stupid AI will be so hyper focused on his single task that he will not realize what else is around. But that is not what we can call evil. It's more related to indifference.
Or foolishness.
Yeah, exactly. But then again, foolishness, it depends. It still requires some kind of moral compass. You see, if you're indifferent, it means that you just focus on your own value. All the rest doesn't matter. So this plays into this idea of aligning these AIs. That if you give an AI like this, the paperclip one, some kind of value for human life, then it will know that killing all humans in order to make paperclips doesn't make sense.
Exactly.
So it's more like I think the whole discourse about aligning goes into how to make AIs like us, but you cannot make a set of rules for it. I mean, the 3 rules from Asimov are a nice example, but you cannot encode all human values into a set of rules. I mean, the advantage we have with this kind of algorithms is that they can learn. So it's much easier to actually teach them our values than fix it in rules. Then yes, of course you can put some hard constraints somewhere, but it will be much easier to have something like that. And that I think is the way to avoid any possible Armageddon, even if I don't think anything like that will happen.
I completely agree with you, actually. There is another. My first remark would be that we have to be careful with these scenarios in the sense that these are prophecies. These don't exist, but these are prophecies that can self-create themselves. But let's put it apart, because that leads far, like how the world works. What was I wanted to say? Yeah, so the other school. And it's important to see this other school, because the actions they propose is exactly the opposite of the actions that the people who were afraid of the singularity Armageddon, the paperclip type Armageddon, propose, which is to put AI into agency carefully. Because they say exactly what you say, which is that the only way to align AI is to make it act, make it responsible for itself, like your kid is responsible for its existence after a while, and you want to bring the kid up so it doesn't hurt himself or herself. So this is this is John Vervaake's master plan, which is also a prophecy. It doesn't exist, and nobody can guarantee that it will happen, as nobody can guarantee that singularity will not happen. Because this is, if we really worked hard, we could create an AI that's indifferent and kills everybody.
Yeah, definitely.
Like, but we don't even need AI for that.
Exactly.
Nuclear weapons. So
yeah.
So because of the prophecy likeness of this thing, I prefer John Vervaake's vision, which is, let's put agency in AI, or AI into agency. Let's put AI into things that are responsible for living in the real world, their own existence, to bind to us and to bind to the world. Same way as you do with your kids. You have no guarantee that your kid will not become evil. Yet we still make kids, and most of the time it works out.
Yeah.
Because there is this tissue of society into which we integrate these beings. Now, of course, this can be scary because these are kind of intelligences that we've never had before. These are not kids. These are coming from the machine world, coming from the, the scientific world.
Yeah.
So it's not that I have like the crystal ball of how to do this, but I would still be for putting agency into AI or putting AI into things that have agency, like a toaster, let's say.
Yeah. But yeah, and at the same time, given the basics on which we train this AI, that is human knowledge, I mean, it is already, so the way we train kids, it helps, it works because they're humans. So there is a basic layer that kind of aligns them already. So training AI on human knowledge, I think it more or less builds something similar. Then we just have to socialize it, because even a kid, if you just don't exclude it from society, and then when it's an adult, you just try to insert into a whatever kind of society, it will be dysfunctional, because you have to do it little by little. But the same is a bit like with these AIs. You have the basic layer, and then little by little you have to domesticate them.
Yes, and this is what's happening with GPT, because what they added was a layer of reinforcement learning where it's, in quotes, socialized or reined in or trained as a dog to behave, right?
Yeah, definitely. Yeah. And I think so I agree with you of the fact that they need to be embodied, because I really believe on the fact that to have real intelligence, you need to be able to act in the world. So today actually I was scrolling Twitter and saw a post, I don't remember from who said that you cannot really build real intelligence just from the propositional level, just from text, because the text we produce already has two kind of filters. So first, the filters between our emotion, our interactions with the world and our internal world. So that already loses some part. And then you express it. So that adds our personal feelings, our personal words, but removes some other part that can be related to our capacity to write or our capacity to express ourselves, whatever. So it's a two layers abstraction from what actually built the intelligences that we are, so the real world. So if we want to build some kind of intelligence that is on par with us and that we can interact on a same level, we need to put it in a setting that is similar to the one that produced humans, so the real world. You cannot just make it learn from text, otherwise it will be it will miss something that you cannot encode.
Yes. Like, actually, I asked GPT how to bike, and it gave me like 12 points. It loves to put stuff into points.
Yeah.
And one of them was, so first of all, it's just propositions. You can put GPT on a bike, it will not be able to ride it.
Yeah.
But the other thing which was interesting is that it told me how to turn to left, which was turn your wheel to the left. And then somebody said that that's a very common misconception of how to turn to the left with a bike. You actually turn the wheel to the right, because you have to lean to the left to turn to left. So before leaning in, you always do a little movement to the right to lean to the left, and then the bike turns itself, actually.
Yeah.
Physics. And even GPT-4 didn't know this, right? Because it somehow it's a statistical machine. And most of the time, when people who don't know this either propositionally, they write about biking, most of the time they have the wrong proposition about this.
Yeah.
So definitely textual knowledge is immense, but it's not everything.
Yeah.
The bias comes probably from, I mean, the bias of thinking that it's everything is coming from our huge success of the scientific revolution that created technology, where one of the normative goals was actually to dispersonalize knowledge. So you share it because propositional knowledge, one of the big advantages is that you can share it easily.
Yeah.
Like you can write it down, you can put it in a computer, you can put it on the internet, and now you can train an AI with it. Whereas your knowledge of how to bike, that doesn't scale. You
Yeah.
can't just magically put it out there and people will know how to bike. You have to teach your kid. It's a complicated thing if you had a kid, you know?
Yeah.
Or how you learn to bike. And that's really just a very basic level, just to show that textual knowledge is not everything. So, still, it seems that there's a lot of fear out there where this AI will go, which was quite understandably motivated by this GPT-4. Between GPT-3 and GPT-4, there was a big jump of capacity of reasoning and things that even researchers didn't foresee. And if I talk to, so I had a conversation on Facebook, for example, with an old friend who had nothing to do with AI, but now he's scared because of GPT-4, but also because of the people, like even researchers, talking about how powerful it is. And he asked me why to do it. Why is this dream of doing AI? Like he said, AI, you got to be 50 without AI. Like you managed to live until 50 without having AI, so why to do it? Now my first answer was that it's not true. Like a lot of things happened in my life and in a lot of people's life because of social media, and we know from Social Dilemma that the algorithms behind content recommendation is AI. It's the same set of algorithms that we have for GPT. But still, it's a valid question. Like, why do we want to do? Why do we want to recreate intelligence or agency or consciousness or whatever attributes we have that like dead objects don't? So, what do you think?
So it's a question I've been posing myself quite often. The first two answers that comes natural for me is first, why not? That is
That's like the guy who has 100% openness on the
yeah. I know it's not a
famous
reassuring
last word
answer.
also.
Yeah, it's not the most reassuring answer, but at the same time, I personally am a very, very curious person. So that's my second motivation. I'm curious to what will happen. I mean, just to see if we're capable of doing it. And then at the same time, from a more serious point of view, I think it helps understanding us a lot as people, as human species, how we think, how we interact, and so if properly developed, if properly tuned, and if not misused, those are a lot of big ifs, I know, but that can really help improve people's lives, not only from a purely economical point of view, but also from a mental point of view. Because if we manage to build something like that, it means that we understand how humans work better, so we can better help people even with a psychology or therapy or whatever.
By you mean by modeling our
intelligence?
And the feasibility of AI would be the proof that we got it right. That's what you mean?
Yeah. I wouldn't say it's the proof that we got it right, because we can, like, as of now, we have a ChatGPT, for example. We don't really understand all the small details on how it's capable of doing what it does and all its emergent abilities. Most of it we do, but not everything. But yeah, I think it can help on that regard, on that line. It can, as any kind of technology, if misused, it can bring a lot of bad things. But that, as of now, in human history, that could have happened so many times. It never happened. I don't see why it should happen now. And if you think about what was happening in the, like, with nuclear power, there were people that were super scared for a reason, but at the same time, it also brought a lot of help, a lot of huge improvements in society and the people livelihood. So that is the answer I give myself to that question. But I'm always looking for more convincing replies.
Yeah, to stillman it, it's important. Yes.
Yeah.
Should try to. Yes. Is there an example from your life where AI helped you to understand yourself better, or in any other way? Like, I give you one, which I wrote in a blog post. I got hooked on fight videos on Facebook in 2020, really badly, like 2-3 hours every night for a short period. So that was I usually have this relationship with addiction, is that I get addicted, but I get rid of it very fast. And so two things happened. I deleted Facebook from my account by my phone. I still log in on the computer, but not on my phone, because I figured that, my part of the brain that gets addicted, that if typically in the evening, doesn't have the capacity to turn it off. But if it's not installed on my computer or my phone, then it will not be able to reinstall it either. But the other more interesting thing that happened was that I realized that among all the things that I could have watched by just clicking on one video or after the other, TikTok is typically this kind of an engine that was built on AI, and it's just giving you whatever your subconscious wants. Still, it's not like they want to give you something very specific. They just want you to be there. So it's something in your brain that decides what you watch. It can be cooking videos or cats or travels. And in my case, it was MMA fights, And so I decided that tells me something about my psychology. It tells me something about what I really want, or some part of my brain wants. And my conscious brain, which was kind of for my conscious brain, it was a kind of strange idea that I want to fight, because I've never done this before. I did other sports, but not mano a mano,
Yeah.
But still, it stayed there. I went into therapy with this, and then I talked to my partner, and then it eventually got matured, the idea that I will do it. And I did it 2 years ago, and it transformed my life. Not every aspect, but in a big part, especially the embodiment part, or getting more conscious about my body, and getting through things that were impossible to understand from propositions, like how does it feel to being thrown over somebody's shoulder and just bump on the ground,
Yeah.
And so this kind of experience was really, really helpful for me, psychologically too, not only for strength and health, but even psychologically. So that is this kind of example what I'm looking for. If you had anything similar, where at least indirectly AI had the effect on you.
Well, so it's yeah, it's more or less related to these recommendation engines, because in the end it's the only AI we act with every day. I realized that I was spending way too much time on Facebook when at one point it started to propose me. So it was just the news, but little by little they were getting more and more depressing.
Oh.
So at one point, because I mean, the war, the COVID and everything, and there is this hooking up part. I guess it was similar to what happened to you, that you realized that you were interested in that. So I realized that there was a part of my brain that was kind of addicted to this kind of anxiety-inducing things. At one point, I just say to myself, I cannot keep on doing that. So I removed Facebook as well. I don't use it anymore. And since then, actually, I'm much happier. I don't know if it's really related to the AI part, but it's the fact that it got so much darker. Sometimes it was also, I've never been a conspirationist, but then when I started to see conspirationist posts on my Facebook page, I say,
that was the end.
What the hell is this? If I don't try to control myself, that can lead wherever. So it never has been such a life transforming experience as you. But it had a small effect, let's say.
Yeah, I mean, it's so interesting, right? That we have this capacity of looking into the abyss, but not jumping, like, okay, that's enough, and then do something drastic.
Yeah. And at the same time, I mean, we can control not to jump, because this recommendation system, I mean, they're very, very addictive, but at the same time, they're very dumb. I mean, like on Amazon, you look for one thing, you buy it, and for 3 months you have recommendation for the same things. Like I don't need 10 pairs of shoes. I just got one. I wonder if we will still have this kind of self-control once this AI become more refined. But
there is one difference there, though, that the AI that gives you the shoe ads, they just want you to buy shoes.
Yeah.
But the AI behind TikTok or Facebook Shorts or YouTube Shorts, they want to pay with your attention. They want you to be there, so then they can sell you ads.
Yeah.
And it's always some money, because that's the only way to, monetize your attention. But it's the reason why they are so addictive is because these companies at the end they want to make money.
Yeah, of course. They engineer this AI with in a way that they can suck up all our attention.
Yeah.
It's also one of the reasons I'm not super comfortable with the current development of AIs, where the most advanced ones are only developed by companies, because I mean the goal of a company is to make money. So this kind of super huge engines will, at one point, will be monetized in a way that we don't really have control over. So when I see all the open source stuff that is going around LLMs and these other parallel chat GPTs, I'm super happy, because I've seen just today a post where you can run your own chat GPT on your computer, or you can have chat with it. Little by little, you can personalize to your needs. So you can have a more personal assistant. And I think that way is also more helpful to understand yourself, because it's like looking in a mirror at one point. I mean, if you train the AI you talk to your own likeness, you can extract things from yourself that you will not notice. It's a bit like going to therapy. You go to therapy, you talk with your therapist, so you can understand yourself. That's probably what will happen. I hope that what will happen.
Yes, I also agree with this, that the individualization of these GPTs will make them much less scary.
Yeah.
And also it will be much more the responsibility of the person who's using it than today, which where now is the responsibility of the company to make it acceptable for like 99% of the people. They don't get scared.
Yeah. And they will become more human friendly. At the same time, to have people being responsible for their own AIs, it will also mean that they will have to understand them a bit better. I mean, at least the risk, like when you drive a car, you're responsible for the car because you know that you don't really know the functioning of the car in detail, but you know if you run over a person, the person is dead. So people will have to be conscious of the fact that not of all the details of how the AI works, but of the fact that if they tell the AI buy drugs, the AI can do it. So that's where the responsibility comes in.
Yeah, and in my opinion, if this happens, there is also another thing that's super interesting. We talked about it a little bit when the agent is responsible for correcting its data. So if you put AI into objects, like a small robot, the small robot, when it comes off the factory, it's identical to all the other robots. But then it gets into an apartment, into a family, and it starts to learn on its own experience. And so it will individuate.
Yeah.
And that's a very interesting subject. It goes far because you know how to transfer knowledge from one individual agent to another. Today, just put it on a disk, you copy it, and you put it into your other computer, and it can run on different hardwares. But once it's individuated, it will not be easy to transfer the knowledge from one agent to another, or mix the knowledge of two agents especially.
Yeah.
Because they won't be mixable, right?
Yeah.
It's really like two twins that are born. In the beginning, they have more or less the same constitution, but they have different experiences. So they grow up to be different persons.
Yeah.
And so this is what I see a little bit with what you said about GPT. If it gets personalized, like everybody's assistant will be different.
Yeah.
And it will be a very interesting world where you could imagine those different GPTs talk to each other. That would be much more interesting, because one of the experiments I tried, this is John Vervaake's, let's say, second person Turing test, where you just make two GPTs talk to each other. And GPT-3 was terrible at it. It converged to nothingness very fast.
Yeah.
GPT-4 is not so bad, actually.
Yeah? Okay.
So GPT-4, if you prompt it right, it can present a subject in a dialogue format. It will still not go somewhere where it haven't gone. Perhaps also because they're reining in.
Yeah.
Reinforcement learning. But it still ends up orbiting around what I call a fixed point. Like giving gratitude to the other and asking the same questions over and over. What it does now, it summarizes the conversation with different words. It's like rephrasing the summary, and this is like where it converges. So it's still not, because it doesn't have any agency, let's say.
Yeah.
And it's all the same GPT. But if you start making two GPTs that were trained on two different persons' history, or for assisting different persons, when they talk to each other, that can be an interesting thing already.
Yeah, definitely.
And I don't really see much danger in this. So this is, as long as it stays in language, it's not good to kill us.
Yeah. The only danger is that it could not really learn, but it could manipulate people to do stuff. But I think that's a separate issue.
Well, that's
Because,
exactly the Facebook issue. I mean, AI
yeah,
already manipulates us, but we have the agency to counteract it.
yeah,
So my example and your example is that we can, if we have to, we can be as drastic as just shut it down. But we can also just react to it and understand, go on a meta level and understand what's happened there and do something for our good, right? And this, if it's gradual, then basically it's, as you said, it's a giant mirror that mirrors you back your own self, and you have the time to react to it to make yourself better,
yeah,
worse. No guarantee. So as you don't have any guarantee that you don't become a heroin addict, right?
Yeah.
So it's the same kind of psychological procedure that leads to an addiction.
yeah,
And you know, if you get rid of heroin addiction, that's also similar to getting rid of social media addiction.
yeah.
In the sense that the only way to do that is to transform yourself, right? Okay, well, this was great.
Yeah.
I'm so happy. I lost my nervousness like 10 minutes into the conversation, and it was so nice.
Yeah, me too. It flew very nice. I really enjoyed it.
So thank you very much, Giuseppe.
Thanks to you. Thanks for the great conversation.
And yeah, see you back in the office.
Yeah.
Okay. Bye.
Bye. See you.